Have you ever really stopped to think about how you experience the world? I mean, really think about it. That feeling of warmth from the sun, the sound of your favorite song, it all feels so instant, right? Well, today, we're going to pull back the curtain and follow the incredible, high-speed journey that a single sensation takes from the outside world, zipping through your body's wiring, all the way to the moment your brain actually makes sense of it all. It's going to be a wild ride.
Okay, let's start with something we can all relate to, unfortunately. Picture it. You accidentally touch a hot stove. It's that split-second electric shock of heat, and your hand is already flying back before you've even had a chance to think, ouch.
So what just happened? Well, that lightning-fast reaction, that's a reflex. It's a super-fast shortcut where the message goes from your skin to your spinal cord and right back to your muscles, bypassing the brain entirely for pure speed. But at the exact same time, another message, a slightly slower one, is taking the scenic route all the way up to your brain. That's the one that lets you consciously feel the pain and think, well, that was hot. Don't do that again. We're going to follow both of these journeys, step by step.
All right, so to really get this, we first need to learn the basic language of your nervous system. You know, what kicks this whole incredible process off in the first place. It all starts with something called a stimulus. Now that sounds technical, but it's really simple. A stimulus is just the trigger. It's the thing that happens. It's the heat from the stove, it's the light from your phone screen, it's the pressure of someone tapping your shoulder. It's any event out there in the world that your body can react to.
Now, here's a really important distinction. Sensation versus perception. See, your body detecting that stimulus, that's sensation. It's just the raw data. Your fingertip registers high temperature. That's it. But perception, that's your brain taking that raw data and making sense of it. It's the brain screaming, danger, hot stove, pull away. The easiest way to think about it is this. Sensation is the raw ingredients, but perception is the finished meal.
So, if the stimulus is the event, who are the first responders on the scene? Who's actually out there gathering all this raw data? Well, let's meet the body's microscopic detectives, your sensory receptors. These sensory receptors are basically tiny biological translators. Their whole job is to take something happening in the physical world, like heat or light or pressure, and convert it into the only language the nervous system speaks, electricity. This conversion process has a fancy name. It's called transduction. So they take the stimulus and transduce it into an electrochemical signal. They're the gatekeepers for every single piece of information that enters your brain.
And these little detectives are total specialists. You've got chemoreceptors. They're like the chemists, sniffing out molecules for taste and smell. Then you have thermoreceptors, which are your body's built-in thermometers for hot and cold. Mechanoreceptors are the physicists. They detect physical force, like pressure or the vibrations from sound. And finally, you've got photoreceptors, which, you guessed it, detect the photons of light in your eyes. Here's a super simple way to keep them straight. Just think, chemo for chemicals, mechano for movement and mechanical forces, and thermo for temperature. It's this beautifully organized system with a specialized detector ready for just about everything the world can throw at you.
Okay, so we've met the general detectives. Now let's zoom in on the elite special ops teams. These are the complex organs built around the receptors that give us our most powerful senses. And we'll start with one of my favorites, taste.
So taste, or gustation if you want to get technical, is all about chemistry. Your tongue is covered in those little bumps, right? Those are called papillae. And hidden inside them are thousands of taste buds. When chemicals from your food wash over them, the chemoreceptors inside fire off a signal, sending it on an express lane straight to your brainstem to be processed.
And these taste buds are tuned to 5 basic profiles: salty, sour, sweet, bitter, and the new kid on the block, umami, which is that deep, savory, meaty flavor you get from things like Parmesan cheese or soy sauce. Each one of these tastes tells your brain something different about the food you're eating. And check this out, here's a cool evolutionary reason for one of those tastes. You know that bitter flavor in coffee or dark chocolate? That comes from compounds called alkaloids, and plants actually produce these as a defense mechanism to stop animals from eating them. So our ability to detect bitterness might have originally been a warning system to avoid potential poisons. Pretty smart, huh?
Next up, audition, or what we call hearing. The ear is an incredible piece of biological engineering. Its entire job is to pull off a magic trick. Turn vibrations traveling through the air into waves moving through a fluid deep inside your head. Let's see how it works.
It's this amazing chain reaction. First, sound waves make your eardrum vibrate. Then, a series of 3 tiny bones, the smallest in your body, amplify those vibrations. This creates waves in the fluid inside that snail-shaped structure called the cochlea. And as those waves move, they bend these tiny little mechanoreceptors called hair cells. And that physical bending, that's the moment of transduction. That's what fires the signal off to your brain.
And here's what's so genius about it. The cochlea is basically unrolled like a piano. The hair cells near the wide entrance respond to high-frequency sounds, the high notes. And the hair cells way down at the narrow tip respond to low-frequency sounds, the bass. So your brain knows the pitch of a sound simply based on which group of hair cells is sending the signal. It's incredible.
But wait, there's more. Your inner ear is also home to your sense of balance or equilibrium. You have one set of structures that tells you your head's position, like if you're tilting forward or backward, and another set, the semicircular canals, that tells you when you're spinning or rotating. All these signals get fed to your brainstem and cerebellum, which act like your body's autopilot, coordinating your movements and keeping you upright without you ever having to think about it.
And now for the main event, our most dominant sense, vision. Your eyes are sophisticated light catchers. Their job is to take particles of light energy, photons, that have been bouncing around the universe and turn them into the rich, detailed visual world you see all around you.
So light streams in, gets focused by the lens, and is projected onto the retina at the back of your eye. The retina is lined with millions of photoreceptors. You have rods, which are amazing in low light but only see in black and white. And you have cones, which need more light but give us our sharp, full-color vision. When light hits them, boom, a signal is sent zipping down the optic nerve toward the brain.
You ever notice how whatever you're looking at directly is super sharp and clear, but your peripheral vision is kind of blurry? That's because of the fovea. It's this tiny little pit right in the center of your retina that is jam-packed with cones. It's your eye's HD zone. And this is a perfect example of how some body parts get way more brain power dedicated to them than others. Okay, so let's recap. A stimulus out in the world triggers a receptor in your body, which creates an electrical signal. But now what? How does that little spark of information get all the way to your brain to be understood? And more importantly, how does it cause you to do something, like pull your hand away from that hot stove? Let's trace the final crucial steps. That signal doesn't just randomly show up in your brain. Now, it first has to go through the brain's grand central station, a structure called the thalamus. Think of the thalamus as the master switchboard operator, sorting all the incoming sensory signals and directing them to the right place. From there, our touch signal gets routed to a special strip of the brain called the somasensory cortex. This is where your brain has a map of your entire body, but it's a really weird, distorted map. Areas with lots of sensory receptors, like your fingertips and lips, get a huge amount of brain real estate, while less sensitive areas, like your back, get just a tiny sliver. And this is so important to grasp. None of it means anything. Not the heat, not the sound, not the light, until your brain puts it all together. So how do we get to action? Well, once the sensory cortex gets that hot signal, it starts talking to other parts of the brain to add meaning. That's a stove. And then it sends the message to your motor planning areas. These areas are like the mission control, coming up with a plan. Objective, move hand away from heat source, now. That plan then gets sent to the primary motor cortex for execution.
The primary motor cortex is the commander. It sends the go signal down a massive nerve highway called the corticospinal tract. That command zips down your spinal cord, activates the right motor neuron in your arm, which tells your bicep to contract, and you snatch your hand back. And all of that, from the initial touch to the sensation, the perception, the planning, and the final action, happens in an absolute fraction of a second. Your reality is literally built from these signals. Which leaves you with a fascinating question. If your brain is building your world based only on the signals it receives, what else is out there that you're not sensing at all? What an incredible system.